Go.
Hello, our name is Hot Wheelers and our app is called AutoTrade. It is a car searching web app that helps users find vehicles based on make, model, and other filters.
In terms of technology stack, we use Python for backend using the Flask framework. It's a lightweight, easy to use, and works really well with Jinja 2 templating, which is why we use which is used to render the front end dynamically. The database is MongoDB. Since we're working with a large unstructured data of car listings, Mongo was the ideal choice because it doesn't require a fixed schema and makes it easy to work with varied data. The front end was built using basic HTML and CSS, but powered by Jinja 2, so the listings, filters, and data could be rendered directly from the backend. To load the dataset into MongoDB, we use the Mongo import tool for CSV files and Mongo files for uploading car images into GridFS, Mongo's file storage system. Overall, the stack allowed us to move fast, handle a large volume of listings, and integrate advanced features like image rendering and geospatial filtering. Now, in terms of process, we start by selecting a dataset from Kaggle, which included a huge number of car listings. We wrote a parser script to clean up the data and extract the first 30,000 usable rows into a new CSV. This involved removing corrupt entries and standardizing things like year and price formats. One big challenge was the dataset did not include usable images, so it built another script, generateimage.py, using the iCrawler library to search for and download relevant car images based on make and model. We started with 100 rows but eventually expanded to 316 image files. Later on, we scaled the dataset up to about 100,000 entries. So during that phase, we also did some extra curation like filling in missing manufacturer and model fields so that the filters would work better. Moving on to the MongoDB integration. To bring the data into MongoDB, we ran the Mongo import command. And for the images, we used a helper script getcars.py that outputs a list of image file names. After importing everything, we ran a few scripts to enhance the data. One was fillcomments.js, which adds an empty comments array to each document. This sets the foundation for future user interactions like reviews or notes. Then there was filllocation.js. This script scans each car listing for valid latitude and longitude coordinates, converts them into GeoJSON points, and builds a geospatial index, which allows us to do location-based searches, like finding cars within a certain radius of selected region by the user. We also added user authentication with create Mongo app user with privileges.js file. It defines a custom role and then creates a MongoDB user with the just the right privileges for our app.
Okay, so to talk about the volume of our data, we're working with a really large data set. Our MongoDB database has almost 100,000 car records in the car details collection. So this is basically all the vehicle listings that our app pulls from. We also use GridFS to handle image storage, which means our car images are directly stored in MongoDB, and it is split between two special collections, which is fs.files and fs.chunks. We have uploaded 317 images, and those are split into 328 chunks behind. And to talk about the variety, our app also gives users variety in how we explore cars. We have a random car generation feature. So if you don't have something specific in mind, we can just click and it'll show a random selection of cars from the database. It always gives you at least 10 cars. And now for the bells and whistles part, which are the extra things we added that go beyond the basics. Firstly, we set up the engine as a reverse proxy in front of our Flask app, and we use Geonicon as the WSGI server that runs Flask. So when you deploy our app on a server, both the proxy and the app service starts automatically. You don't need to manually restart anything. If the server reboots, it's just ready to go. So we also used Flask's proxy fix module to handle proxy headers correctly in the production, which is important if we deploy this publicly. So another thing we have added is geospatial search, where users can search for vehicles near a certain location by using a radius filter. And finally, we are also using Python libraries to convert between GPS coordinates and actual location names. That means the app understands both coordinates and real place names when it comes to when you want to filter cars by location.
So the app homepage looks like this, showing just some information about the what the site's about, has some header information at the bottom about our class, what the project is for, a copyright of this year and our team. If we go to search random cars, we can retrieve any number. If I press this again, there's some more random cars. If we go to, let's say, 100, we get 100 random cars. If we want to click on one of these, we can click on it and you can see some information about the car, and comments can be added, which will be shown in a second. So you can see all these details, image, and this one I believe is default because it doesn't match, but that's okay. Going to search for cars, you can search anywhere, which is not a random list, just is limited to 20 by default. You can do, let's say, 200, and a list of all those will show up. Now, by default, it'll filter generally anywhere, but all the locations inside of our data set can be used. So for example, if we wanted to search for cars in the Bay Area, we could do a search like this. We can narrow the radius to be a little smaller, so we could do something like 5 kilometers, and there's a lot less entries, even though our list limit is 200. Has image will search, well, this may not show up here, but if we search for cars that have an image, they'll be one of the 316 in the list that do have images added specifically, so you can see that. This one is showing up. Yep. So this car is one that has a specific thing, and you can tell it's GMC. And if you want to show no image, the ones that have defaults, you can go here, and a lot of these will be just the default image. Now, and then one more feature of the search that's really important is the ability to search by name, which is case insensitive. So you can see Lexus is here, and if I were to take one of the letters, for example, and change the capitalization, I can still be able to search for it. Let's say we really like a car, we can go here, and we can say this, just type in, is a great car. So I can say this is a great car. I submit it, and the comment shows up here. Any other comments added will show up. Now, the last thing is the listings, which shows a random list of many cars, but it can be narrowed down by the type. This is a filter. So we can filter by Acura. If we wanted a, let's say, Mitsubishi, we could do this. And then we can also filter by location. So if we just did without, just in general, we have this. These are all the San Francisco Bay Area. This one is, let's say, Eastern Connecticut. All these are different cars. We do a Cadillac in Eastern Connecticut, shows these specific entries, and we can go here and see the information there. And that's it. Thank you.